In the course of finding zeros of a polynomial, it's very important to look onto fundamental theorem of algebra. Let's suppose f of x is a polynomial of degree n, where this degree is greater than 0. Then the fundamental theorem of algebra says that there is at least one zero of this polynomial. A corollary or the consequence of fundamental theorem of algebra clearly states that polynomial of degree n has exactly n roots or n factors. Okay, so a consequence, n zeros or can be factored into n factors. Okay. And where some of these zeros might be repeated, then we can write this as f of x equals to a times x minus c1, x minus c2, and up to x minus cn, where this c1, c2, cn are complex numbers. So the corollary says that polynomial function of degree n has exactly n zeros, or the polynomial can be factored into exactly n factors, where some of these factors may be repeated. Let's take a note. Complex zeros of a polynomial. Complex zeros of a polynomial occurs in conjugate pairs. So what this is saying is that if a plus bi is a complex zero of a polynomial f of x, then the complex conjugate of this number is also a zero of f of x. Then a minus bi is also a zero of f of x. Now let us take an example involving this idea and the idea given by the fundamental theorem of algebra. Let's take an example where we need to find a polynomial of degree 3. That means the highest power of x is 3, with zeros 5 and 2i, where 2i is a complex number or simply imaginary number. Let us consider fx to be the polynomial having such criteria. The degree is 3 and zeros 5 and 2i. So we already know 5 and 2i. There are two zeros, and what is the next zero? So since 2i is a zero of f of x, so negative 2i, the complex conjugate of this number 2i is negative 2i, is also a zero of f of x. Okay, so you can see that x equals to 5, x equals to 2i, and x equals to negative 2i. These are the three zeros of this polynomial, which can be written as x minus 5 equals to 0, x minus 2i equals to 0, and x plus 2i equals to 0. Thus, the required polynomial f of x is of the form f of x equals to x minus 5 times x minus 2i times x plus 2i. We can write this as x minus 5. If we multiply conjugate numbers, then it just becomes x square plus 4. Okay, let's multiply these two factors, then we'll be getting x cube minus 5x square plus 4x minus 20. So the required polynomial is this one.